Test procedures for particulate matter and/or filtration time. Pause and read this note before proceeding. Grounding bonding of filtration apparatus. The filtration apparatus becomes a prolific static generator as fuel is pulled through the membrane filter. Thus, the flask and apparatus must be grounded or bonded to the laboratory common ground. This is accomplished using number 10 through 19 bare strand flexible stainless steel or copper installed on the flask as shown in figure C5. When a metallic flask is used instead of glass, the flask must be grounded.
When there is no continuity, it is necessary to install an additional jumper wire between the funnel and filter base. Drill and tap the bottom of the filter holder to accommodate a small screw to fasten the wire, which connects to the filter funnel and the laboratory ground.
Step 1. Clean the stainless steel filtration apparatus by rinsing with petroleum ether.
And then make sure you get the little blue disc there on the outside as well. Excellent.
Step 2. Place new membrane filters in a petri dish with the lid slightly ajar in an oven for 30 minutes at temperatures of 90 degrees Celsius, plus or minus 5. Remove the petri dish from the oven and place near the balance for a minimum of 30 minutes. The petri dish cover should be slightly ajar, but still should be protecting the membrane filter from atmospheric contamination.
Step 3. Remove the membrane filter from the petri dish with forceps, handling by the edge only, and weigh to the nearest 0.001 gram. Step 4. A control membrane filter shall be prepared as prescribed above and placed under the test filter on the control base. Step 5. Attach the top funnel into place. Step 6. Clean the top exterior portion of the sample container with petroleum ether. Step 7. Shake the sample for 15 seconds to obtain a homogeneous mix prior to filtering. Step 8. With the vacuum off, pour approximately 200 milliliters of fuel into the funnel and check for leaks. Turn the vacuum on and record the starting time. Continue filtration of the sample, periodically shaking the sample to maintain a homogeneous mix. Note the vacuum in inches of mercury at 1 minute after start. The vacuum must be greater than 20 inches of mercury. Throughout the filtration, maintain a sufficient quantity of fuel in the funnel so that the membrane filter is always covered. Step 9. Should the sample exceed the 30-minute filtration time and a portion of the fuel is not filtered, the solid contents in milligrams per liter will be figured as follows. Determine the volume of the fuel filtered by subtracting the milliliters of fuel remaining from 3,785 milliliters. This condition does not constitute failure, however, it does require investigative action to determine the cause. Step 10. Shut off the vacuum and rinse the sample container 4 times with approximately 50 milliliters of petroleum ether. Turn on the vacuum and filter, rinse. Step 11. Wash down the inside of the funnel and the outside joint between the funnel and the funnel base. With the vacuum applied, carefully separate the funnel from the filter base. Rinse the membrane with a gentle stream from the outside edge of the filter towards the center. Do not rinse the particulates off the filter. Maintain a vacuum for a few seconds to remove excess petroleum ether. Step 12. Using forceps, carefully remove the test filter and place in a clean petri dish. Remove the control filter when used and place beside the test filter in the petri dish. Dry and reweigh the membrane filters as described in steps 2 and step 3 above. Use the following formula to convert milligrams per gallon to milligrams per liter. Report the contamination to the nearest 100th milligrams per liter. Also report the sample volume used in the test. This concludes the gravimetric analysis overview. This is for training purposes only, and as always, consult the most up-to-date tech data available.